Brothers and sisters. Today I will be showing you guys how to list all the possible real roots and possible roots of the following functions, the polynomials, and then we're going to graph polynomials, and then we're going to write polynomial equations from text. All right, let's get started. So first, as you can see, there is no b here, so you already know that finding the x-intercept is going to be a difficult task. First, let's just focus on finding the possible roots, which is just p over q, or the last number, the constant, over the leading coefficient. Our leading coefficient is 1 and our constant is 48. So let's just see what it's divisible by, literally. So it's 48 over 1. You already know we got 2, oh, sorry, not 2, but 24, 16, 12, 8, 6, 4, 3, 2, and 1. Yeah. So these are all of the possible roots. Let's just parentheses all of these so it's easier. So P possible could be any of these, right? And to actually know which ones of them are the real roots, I believe that synthetic division is the most efficient way of finding the answer to that. Let's try putting in, yeah, let's do like a 2. So 2, when you put 2 here, when you want to synthetically divide, you write the numbers of each of these values. So x would just be 1, negative 4x, so negative 4, you got negative 20, and you have 48. What do you do with these? Well, 1 comes down, and now 1 is times 2, so that's 2, and then 2 minus 4, negative 4, is negative 2. Negative 2 times 2 is negative 4. Negative 4 plus 20, negative 20 is negative 24. Negative 24 plus 2 is negative 48. That is 0. So we found our first factor, our first 0 is a factor. That is our first 0. So we can confidently say x minus 2. All right, let's try another one, like eeny, meeny, miny, mo, catch a tiger by his toe. 6. Let's try 6. So if we put 6 in here, right, we got 1, negative 4, negative 20, 48. Okay, let's get it. 1 goes down here, 1 times 6, 6. We got 2. 2 times 6, 12. Right, and then that is just 8. Negative 8. Negative 8 times 6, 48. So negative 48, that's 0. So this is also a factor, is a factor. All right, let's try 4. All right, we got 4. Let's just zoom through it. We got 1, negative 4, negative 20, 48. All right, let's get it. 1 down here, 1, 4, 4, 0, 0, 0. Wait, not 0, sorry. But 0, negative 20. Negative 20 times 4, that's just, yeah, this does not work. 4 does not work. Let's do the negative version of it. So negative 4. 1, negative 4, negative 20, 48. You got 1 down here, negative 4. That's just negative 8. And then, yeah, negative 8 times negative 4. 8 times 4 is 32. 32 positive 32. So, yeah, that's just 12. 12 times 4. Wow. Yeah, now that's 48. So that's negative 48. So that becomes 0. So this is a factor indeed. Okay, I think that's about it. It's not more than 4, right? It's not more than 3, right? Probably not, because that would be absurd. But alright, I think so. I think it's just okay. 2, 6, negative 4. Those are the zeros. We have found the roots. So that is how you synthetically divide using possible roots. You just plug in any of these to see which one works, honestly. I was really lucky for not making few mistakes here, but let's go on with the next one. We have negative x to the power of 3 minus 2x minus x to the power of 2 plus 9x plus 9. All right. Let's find the possible roots, right? So we're using rational root theorem. As you know, it is constant over leading coefficient. So okay, 9 is just not okay. Let's just write it because it's definitely just plus or minus 9. 3 and 1, because that's the only thing that's divisible by 9. So all right, but now, like, knowing this, we know that we can find the zeros now. So if we just plug in, for example, let's go for negative 1 again, like we did positive 4, but here let's try negative 1. Yeah, negative 1, negative 1, negative 1, positive 9, positive 9. All right, we bring the negative 1 down here. Negative, negative, positive, positive 1, 0, 0 times 0, 0, 9, 9, negative 9. That is 0. Wow. Okay, this is a factor. This is a factor. So one of our factors is actually plus x plus 1. Okay, let's try 3 because that's the other one. That's because we see 3 here, right? So let's just try plugging it in. 3. All right, x. We got negative 1, negative 1, 9, 9. Oh, wait, okay, negative 9, okay. You bring that down, and then you multiply it, so that's just negative 3, negative 4, negative 4 times 3, negative 12, 3, negative 3. Negative 3 times 3 is negative 9. That's also 0. This is also a 0. So we can confidently say x minus 3. And these probably only go up to 2. So let's just plug in like 3, like negative 3 instead of that. So if we do negative 3 now, I'm going to do negative 1, 9, 9. And then you bring that down, so it's negative 1, positive 4, 4. Yeah, it's just 3, 3, 9, negative 9, 0. Wait, hold up. I think I messed up somewhere. Yeah, no, this is not 4, that's 3. Yeah, that does not add up. Yeah, that's 3. Yeah, 2, and that's just negative 6, 7, 8, 9, 3. 3, 9. Okay, there we go. So that's 9. So this is also a factor. Confidently we can write x plus 3. Alright, that's pretty much it. You just do the same thing for all of them. You find a possible root from the rational root theorem, RRT, which is constant over leading coefficient number, and you just keep going. You just keep writing the roots and plugging them in and finding the zeros as I just did. Now I think it's really important to show you how to graph the polynomials again, as I have discussed in another video. Let's start with the one with the leading coefficient, because I know everyone's going to get tripped up on these ones because they have the leading coefficients. So first, in order to find the zeros, we have to use the rational root theorem, which states negative 24 over 4. All right, let's find all the possible roots for this thing. Possible root, let's go. Wait, okay, this is not enough space. No, I need to factor these first. Yeah, this is factorable by 4. Yeah, I can just yank it out. So 4 x 4, and then you got like 2 plus x minus 6. There we go. It's looking a little bit more neater. This doesn't look right. This is a bit weird. I don't know what's up with this. All right, let's try it. Wait, actually. Okay, let's try it. So negative 6 over. Okay. Negative, because if it's okay, you can't have a negative like that. You can't do that. The possible roots are 0. Possible roots equals 0, because you can't have that. You can't have that. No, you can't have that. So yeah, you can't have that. So we have this, which is 0. That's a root 0, and then you have to factor this, which is just x plus 3, x minus 2. Yeah, that checks out. Alright, that would be like x equals 0 to negative 3. Yeah, that makes sense. Okay, because you can't do possible roots with that one. You can't do that because it has a negative. It has a negative. What's it called? End. It has a negative constant. You can't do that. You can't have a top negative constant. So there you go. All right, what does it look like? Let's see. All right, let's go. All right, we got a nice graph like that. All right, that is how we graph the first one. All right, next one. This is also a negative constant. We can't keep having these, man. If we have these, we can't do possible roots because it just doesn't work like that. It just doesn't work like that. You can't factor it out like that. So, okay, let's try this. Let's try this one. You can rearrange these so that it faces like this. So x to the power of 3 minus 8, I guess, and then let me look at this a little more closely. Actually, no, wait. You can put this in. Yeah. You can possible root this. Why not? Okay, you could do like Okay, -8 or 8. Yeah, you can possibly read this. Yeah, you can possibly read this. P equals plus or minus 1, 8, 2, 4. Yeah, let's get it. Alright. I mean, instead of plugging all of that in, do we need to plug all of this in? Because, well, I'm gonna pause this. Alright, I guess so. We gotta do it. We gotta go through with the process of synthetic division, because it does not seem like you can just do what you did here. So 1 times, it's just negative 6, negative 6, negative 6, and 6 is that. Whoa, blow. Oh my god. 8, that's 0. Okay, we got our first one, which is x minus 1. Let's go for like 4, I guess. 4, 1, negative 7, 14, negative 8. We bring this down, it's 1 times it's 4, so 3, negative 3, negative 3, negative 12, it's just 2, 8, 0. Okay, we got 4 too. Wow, I'm on a roll. Alright. 2. I got literally just 2 left. So let's just do 2. No negatives. 1, negative 7, 14, negative 8. Alright, let's go for this one. We got 1, 2, 7, 2. 5. Negative 5. Negative 10. 4, 8, 0. Alright, we got x negative 2. Okay, these are our zeros. 1, 2, 4. Alright, let's plot them. 1, 2, 4. Wow, this is pretty basic. Like, okay, this is obviously a positive odd graph, so it just goes like this. It just goes like this. Wait, hold on, let me draw the little figurine that I used to memorize these with. Yeah, like that. Yeah, that's pretty much how you solve that. Well, let's get to these ones. Function with zeros at that and that. Alright, let's get to it. Yeah, I kind of look back at this and it's long, so let's get started. First, we need to actually write these in the factored form so we could FOIL them into standard form. So we got an x, which is our 0. We got a x minus rad 3, and we got a 5, so x negative 5. Right, let me bring the mic closer. And what we got to do with this now is, let's just give that to that. Actually, no, let's do that. Yeah, let's do this right now, actually no, wait, okay, I'm second guessing myself. I shouldn't be doing this. Alright, x squared, we got negative 5x, and then we got negative root 3x, and then we got positive 5 root 3. Yeah, that's right. Okay, And it's just multiplied by x. Yeah, wait up. Yeah, that sounds about right. So multiply by x, so it's just x to the power of 3 minus 5x squared minus root 3x plus, plus 5 root 3x. I think these get added. Yeah, this gets 2. And yeah, that's pretty much it. That's your answer in standard form. You just FOIL it. You just write the factored form and then FOIL it. Same thing for here. This one, we need to write it. So first we got our x minus 4. Then we got our x minus 6. Then we got our x... I believe that's minus 2i. Yeah, I believe so. Alright, we're back. Oh, this was also negative, I forgot. Yeah, negative function with zeros. Alright, let's go. So, when that becomes negative, this becomes positive, this becomes positive, this becomes negative. Alright, so when we have this, I mean, this is technically a conjugate because it's 2i, so it could be like x plus 2i and x minus 2i because it's a conjugate. We always need to remember that. So we need to find a now because we need to like use these points essentially. So let's find it. All right, we got let's plug in the y's, the x's here. So 0, negative 4, and then we got 1, and then we got 0, negative 6, and then we got 0, negative 2i, and then we got 0 plus 2i. Okay, I'm back and I actually made a fatal mistake. This was x to the power of 2 plus 4i because this is the conjugated version of this. So I put it back into factor form because it wants it in factored form. So now that I want to find a, I'm putting these as 0 because this is the x-intercept of 0. So what I'm essentially left with is negative 4 times negative 6. What does that equal? That equals 24. Now 24 times negative 4, because 4i is just 4 times negative 1, right? And what does that leave us? That leaves us with negative 96. And what do? You put negative 96a equals to negative 24. And when that happens, you divide negative 96, and then negative 96. All of the negatives cancel out. And what that leaves you with is a equals to 24 over 96, which is 0. You don't even need to do that because because the decimal version of this is 0.25, which is just 1 over 5, if I'm not wrong. Let me Google that. I'll be right back. Oh, my bad. It was 1 over 4, not 1 over 5. Oh my god, that was a fatal flaw, according to Bing.com. Okay, yeah, so it's 1 over 4. So A is 1 over 4. And what that leaves us with is the final answer here, which is going to be, okay, 1 over 4. Oh, yeah, 1 over 4, and then parentheses, x minus 4, and then x minus 6, and then x squared plus 4. Oh, yeah, plus 4. I doubted myself for a second. That's not a bracket. That's a parentheses. But yes, this is the final form of that. I'm glad all of you enjoyed this video. See y'all in the next one. Bye bye.